Hi guys, welcome to another episode of Learn with Sir Glenn, and for this video, we're going to discuss measure of angles formed by secant and tangent. So, let's go! Measure of angles formed by secant and tangent. On our previous video, we discussed that the angles formed by secant and tangent are grouped into three. So the first one, the angle formed inside the circle. If the angle is formed inside the circle, you can easily get the measure of your angle by getting the 1/2 of the sum of the intercepted arcs of the vertical angles formed inside the circle. Next is the angle formed on the circle, just like these examples of angles. So if the angle is formed on the circle, then the measure of angle is equal to 1/2 of its intercepted arc. Then the last one is the angle which is formed outside the circle. Its measure is equal to 1/2 of the difference of its intercepted arcs. So how do we solve for the measure of angles formed by secant and tangent? To make it easier to solve for the measure of angles formed by secant and tangent, let's follow these steps. So first, we have the location. So we have to determine whether the angle is formed inside, on, or outside the circle. Since the formula for the measure of your angle will depend on its location, so this will be the first step. If the angle is formed inside, you get 1/2 of the sum of the intercepted arcs of our vertical angles. If the angle is formed on the circle, you have 1/2 of its intercepted arc. If the angle is formed outside the circle, you will have 1/2 of the difference of its intercepted arcs. After determining the location of your angle, you can now formulate an equation. So we're going to make an equation using the relationship of the angle and the intercepted arc or arcs. Then we're going to do substitution, where we're going to substitute the given measure to your equation. After that, all we have to do is to have our solution, which is solving for the missing measurement. Then of course, lastly, we will have the answer or your final answer. Now let's use the following steps to solve for this one. So given the figure, solve for the measure of angle BAC. Since angle BAC is missing, first thing that you're going to do is to locate angle BAC. And for this one, we have the angle BAC is an angle formed on the circle. So therefore, the measure of angle is equal to 1/2 of its intercepted arc. So we're going to use this one to formulate an equation for solving the measure of angle BAC. So since our angle is angle BAC and its intercepted arc is arc BC, then we can say that the measure of angle BAC is equal to 1/2 of the measure of its intercepted arc, which is arc BC. The next step is to substitute. So we're going to substitute the given measure on our figure, which is 84 degrees for arc BC, to our equation, giving us measure of angle BAC is equal to 1/2 of 84, replacing measure of BC with the given measure, which is 84. And all you have to do is to solve for this one. So measure of angle BAC is equal to 1/2 of 84. Dividing 84 by 2, we will have measure of angle BAC is equal to 42 degrees. So we have measure of angle BAC is equal to 42 degrees. Okay, now let's have this figure. So given the figure, solve for the measure of angle BEC. So first, locate angle BEC, and it is actually an angle formed outside the circle. So since it is formed outside the circle, then its measure is equal to 1/2 of the difference of its intercepted arcs. So for our equation, we will have measure of angle BEC is equal to 1/2 of the difference of the intercepted arcs, which are measure of arc BC minus measure of arc AD. Then after this, we're going to substitute the given values. So we have BC is equal to 84 and AD is equal to 36 degrees. So we will have measure of angle BEC is equal to 1 half of 84 replacing BC minus 36 replacing AD. Then all we have to do is to solve for this. You may disregard the degree sign first when you are solving. So we will have measure of angle BEC is equal to 1 half of 84 minus 36. Then solving for this, we will have measure of angle BEC is equal to 1 half of 48, which is equal to 24. So therefore, measure of angle BEC is equal to 24 degrees. And let's have another example. So given the figure, solve for the measure of arc AD. First, we're going to determine the location of the given angle, which is angle AED. And angle AED is an angle formed inside the circle. So since it is an angle formed inside the circle, the measure of this angle is equal to 1 half of the sum of the intercepted arcs of the vertical angles. So we can use this one to formulate our equation, which is measure of angle AED is equal to 1 half of the measure of arc AD plus the measure of arc BC. Then after this, we're going to substitute the given measures on our figure to our equation. And that will give us measure of angle AED is equal to 86 degrees and measure of arc BC is equal to 95 degrees. So therefore, we will have 86 degrees replacing measure of angle AED equals 1 half of the measure of arc AD plus 95 degrees replacing measure of arc BC. Then after this, we're going to solve for our equation. So to remove the 1 half, we multiply both sides by 2 so that we can cancel 1 half and 2. Then the left side of our equation will become 2 times 86, which is 172. Then the right side will become measure of arc AD plus 95. So solving for the measure of arc AD, so we have to isolate the measure of arc AD on one side of the equation. So we will have 172 minus 95 equals measure of arc AD. Continuing this one, we will have 77 equals measure of arc AD. So therefore, measure of arc AD is equal to 77 degrees. Okay, so let's have another one. So given the figure, solve for the value of x. First, we have to determine the location of the given angle, which is angle BDC, and it is an angle formed outside the circle. Since it is angle formed outside the circle, its measure is equal to 1 half of the difference of its intercepted arcs. So therefore, our equation will become measure of angle BDC is equal to 1 half of the measure of arc BC, the bigger arc, minus the measure of arc AC, the smaller arc. We'll have 54 degrees is equal to 1 half of 192 degrees minus x. Then solving for this, so we have to remove your 1 half by multiplying both sides by 2, and that will give us 108 is equal to 192 minus x. So solving for x, we will have 108 minus 192 equals negative x, and that will give us negative 84 equals negative x. Then we divide both sides by negative 1. Then we will have x is equal to 84 degrees. Okay, so let's try another one. Solve for the value of x on our figure. So again, we have to determine the location of our angle, which is angle BCD, and it is an angle formed on the circle. So therefore, the measure of this angle is equal to 1 half of its intercepted arc. And after this, we're going to have our equation. So the measure of our angle, which is measure of angle BCD, is equal to 1 half of its intercepted arc, which is arc BC. Then we're going to use the given measures on our figure to replace the measurement on our equation. And that will give us 108 degrees replacing angle BCD is equal to 1 half of 3x minus 9 replacing measure of arc BC. Then to solve for this, we multiply both sides by 2, and that will give us 216 is equal to 3x minus 9. Then isolating your x variable on one side, we will have 216 plus 9 equals 3x. That will give you 225 equals 3x. Dividing both sides by 3, we will have x is equal to 75. Okay, so let's have the last one. So in our figure, solve for the value of x. So first step, determine the location of the given angle, which is angle CAT, and it is an angle formed outside the circle. So the measure is equal to 1 half of the difference of the intercepted arcs. After this, we're going to formulate an equation, So our equation will become measure of angle CAD, which is our given angle, is equal to 1/2 of measure of arc DC minus measure of arc BD, which are the intercepted arcs. And we're going to use the given values on our figure to replace the measurements on our given equation. So we will have 5x plus 5 replacing angle CAD is equal to 1/2 of 168 replacing arc DC minus quantity 6x minus 2 replacing measure of arc BD. Then solving for this, so we multiply both sides by 2 to remove the 1/2, and that will give us 10x plus 10, that is 2 times 5x plus 5 is equal to 108. Distributing minus sign to quantity 6x minus 2 will give you negative 6x plus 2. Then all we have to do is to simplify this, combining like terms. So we will have 10x plus 6x is equal to 168 plus 2 minus 10, and that will give us 16x equals 160. Divide both sides by 16, then x is equal to 10. Then you can use now this value to solve for the measure of angle CAD. So since measure of angle CAD is 5x plus 5, replacing x by 10, you will have 5 times 10 plus 5, which is equal to 55. You can also use this one to solve for the measure of arc BD. So arc BD is equal to 6x minus 2. Replacing x by 10, we will have 6 times 10 minus 2, which is 60 minus 2, which is 58 degrees. Okay, that's it. Thank you for watching and hope you have learned something from this video.